Welcome to section 15.3, part 1. This is the 160th session of the CISSP exam prep series. In this session, we'll look at how to catch flaws in code before it ships. We'll answer several questions. Why does software deserve such careful testing? How does peer review harden your code? What is the difference between static and dynamic testing? What extra tools sit alongside them? And what do you owe a vendor when you find their flaw? Why does this matter beyond the exam? Because a single, unchecked line of code can undo every other control. Picture a fintech startup that ships a payment feature under deadline pressure, skipping review. One overlooked input flaw becomes the breach that makes the news. Testing software is how you stop that story before it starts. On the job, you are often the last set of eyes standing between a developer's shortcut and a production incident. So why does software deserve such careful testing? Because it holds enormous power over everything else. Applications often run with privileged access, handle sensitive data, and lean on databases full of secrets. When they fail, the business can grind to a halt. There is a core design principle here. Software should never assume users behave well. It should expect the unexpected and handle bad input gracefully, a discipline called exception handling. Build software like a bank teller who calmly handles the customer, trying every trick in the book. How does peer review harden your code? By putting a second set of trained eyes on it before it ships. In a code review, developers other than the author examine the work for defects. The review either clears the code for production or sends it back with fixes to make. The most rigorous version, a formal inspection, follows 6 defined stages, from planning through follow-up, each with strict entry and exit criteria. Reserve that heavy ceremony for code where a flaw could be catastrophic. It is the difference between a quick proofread and a full editorial board. What if a formal inspection is overkill? Then you use a lighter touch, which most teams do. You might have a developer walk the team through their code in a meeting. You might require a senior developer to read and sign off on everything before it goes live. Or you might lean on automated tools that flag common flaws before code reaches production. The right process is the one that fits your business and your development culture. Match the rigor to the risk, not to a rulebook. What is static testing? It is checking software without ever running it. Static analysis inspects either the raw source code or the compiled application, usually with automated tools that hunt for common flaws like memory overflows. Because it never executes the code, it can run early and often, right inside the development process. Mature teams hand developers these tools to use as they build, not just at the end. Think of proofreading a recipe for dangerous steps before anyone turns on the stove. Then what is dynamic testing? It is the opposite, checking software while it runs. Dynamic analysis evaluates the application live in a runtime environment, which is often your only option when you did not write the code yourself. A common example is a web scanner probing a running application for injection or scripting flaws. One powerful technique is the synthetic transaction, a scripted action with a known expected result. You run it, compare the output to what you expected, and any mismatch flags a possible bug. Just coordinate carefully, so live testing never disrupts real users. How do you know the software performs well enough? You measure it against a benchmark. A benchmark is a predefined baseline that a system should meet or beat, expressed in metrics like response time, throughput, error rate, and resource use. You watch those numbers under normal load and under stress, then compare against the baseline. If the system falls short, you have found a performance problem to chase. A benchmark is the finish line time you set before the race, so you know whether the runner actually kept pace. What other testing terms should you recognize? 2 round out the picture. Interactive testing analyzes an application's behavior in real time as it runs, watching its traffic, its components, and its back-end connections all at once. Self-protection is different. It runs right on the server, intercepting the calls flowing into and out of the application and validating those requests as they happen. One watches to learn, the other steps in to defend. Together they blur the line between testing and live protection. What do you owe a vendor when you find their flaw? A responsible, private heads up before the world hears about it. Security professionals often stumble onto unknown vulnerabilities in someone else's product. Ethical disclosure says you tell that vendor first, giving them a fair chance to build a fix. You also give them a reasonable amount of time to act. If they never do, you may responsibly go public, so other professionals can protect themselves. It is the courtesy of knocking before you shout, balanced against the duty to warn everyone else. So let's bring it together. Software earns careful testing because it is powerful and failure-prone, so design it to expect the unexpected. Code review puts peer eyes on your work, from formal inspections to lightweight sign-offs. Static testing checks code at rest, while dynamic testing checks it running, backed by synthetic transactions and benchmarks. Interactive testing and self-protection extend that toolkit. And when you find another vendor's flaw, ethical disclosure guides how you tell them. The MCQs covering all the topics and concepts from this session are available on rootcloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.